In this section, we're going to learn another method to solve an equation that looks like this. Here I give you the example, 0 equals negative 4z squared plus 7z plus 5. What are the different ways we have that we could solve this? Well, one option is we could try and factor this into two binomials multiplied together, and then we could set each factor equal to 0 using the zero product property. As a reminder of what this looks like, we'd be trying to find numbers to fill in the blanks shown below, such that when we multiplied it out using FOIL, the result was the equation above, negative 4z squared plus 7z plus 5. But sometimes things just don't factor neatly. We don't end up with whole numbers when we're factoring it, and it gets really messy. A second option that we have is something called completing the square. In this case, we use a little bit of clever addition in order to make the thing on the left side be a perfect square binomial. And then we take the square root of both sides. We'll do more of this towards the end of Chapter 10, but you can see below that this involves adding fractions together, which can give us trouble a lot of the time. This looks kind of ugly. A third option that we've already learned is to graph the function that goes with this equation and find the zeros of that function. If we did that, we would see that our graph would look something like what's shown here. And when I look at that graph, I can't tell exactly what the points are where that blue parabola crosses the x-axis. I can't tell exactly what x has to be to make y be equal to 0. So what other ways do I have to solve this equation? Enter the quadratic formula. When you have a quadratic equation in standard form, that is, ax squared plus bx plus c equals 0. It's important in this case that it's all set equal to 0 and that there is a single squared term, a single x term, and a single constant term. We have a quadratic equation in standard form like this. We can find the solutions, that is the numbers I can plug in for x that make the left side of the equation be equal to 0, are given by the following formula. X equals negative b plus or minus the square root of the quantity b squared minus 4ac, all of that stuff over 2a. That looks really ugly and nasty, but you'll find once you start using it that this formula can be your friend. If you find that you have trouble remembering this particular formula, if you do a search on YouTube, you'll see that there's lots of different people who have set this formula to music, and you can sing the formula if it helps you remember it. You will need to have this formula committed to memory. So how do we use the quadratic formula? Well, let's say we have a problem that looks like the one shown here. The first thing we need to do is to find out what values of z in this case are going to make this equation true. That is, what values of z will make the left side equal to the right side. First, I need to get the equation into standard form. To do this, I need to subtract 6z squared from both sides. When I do that, I get 0 equals negative 4z squared plus 7z plus 5. Notice that on the left, I have it equal to 0, and on the opposite side, I have a z squared term, a z term, and a constant term. Then, you want to identify what are a, b, and c for this particular quadratic equation. You really must write down on your paper the values of a, b, and c, including the signs. If you don't, you will make errors and lose points in just how you plug numbers into the quadratic formula. In this case, a is negative 4, b is 7, and c is positive 5. Now I can take these three values and I can plug them into the quadratic formula. The quadratic formula in this case says z is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All I've done below is replaced b in the equation above with the number 7. Replaced a in the equation above with the number negative 4. Notice that I did that in two places, underneath the square root sign on the top and on the bottom. And I've replaced c in the equation above with 5. Now all we have to do is very carefully do the arithmetic contained in this formula. Please be careful of your signs while you're doing this. So first I'll start out by looking underneath that radical sign, the square root sign. 49 minus negative 80, well, minus a negative is the same thing as plus a positive. So the stuff under the square root sign simplifies to 129. So I have negative 7 plus or minus the square root of 129 over negative 8. Now at this point, we need to make sense of this little plus or minus sign. What that really means is that there are two separate equations shown here. One of them is the plus equation, and one of them is the minus equation. In order to make the arithmetic a little easier, I'm going to rewrite the square root of 129 in its decimal form. I do that on my calculator, and I see it's approximately 11.36. Now, I'm going to break this into two equations, the negative 7 plus equation and the negative 7 minus equation. So first, I'll do the plus version of that equation. Negative 7 plus 11.36 divided by negative 8. When I add the numerators and then divide by that denominator, I see that what I get is z equals negative 0.54. That's one solution. Then I'm going to solve the minus version of this equation. Z equals negative 7 minus 11.36 all over negative 8. When I do that, I get z equals 2.29. So these two values of z, negative 0.54 and 2.29, those are the two solutions to this equation. They're the two numbers that I can plug in for z that make my original equation be equal to 0.